Hello everybody, I'm Vishal. Okay, we can see we are here to present a presentation for a company which is into manufacturing of this kind of customized vehicle. The name of the company is Rito. We can see this kind of customized vehicle are manufactured by this company. I'll show you one more example. This is again a Magnum Q example. But we are mostly interested into the rim part of it because the unit that we are working on is into manufacturing of wheel rims. As you can see, there are wheel rims which are attached to the wheel part of this particular vehicle. So let's go and let's get started with our presentation. I'll just log into the vault of my enterprise PDM. I'll log in as a designer where I need to start designing the wheel rim. Before designing it, I'll just show you the subassembly of the complete wheel that I have here. I can just go to the local view of my enterprise PDM. I'll just show you the variation here. I have the assembly, that is the sub assembly of the complete wheel. So you can see this is the complete sub assembly of the wheel that we can see here. There are different parts of the wheel. We can see this is a brake drum that we can see in front of us. You can just go and see the other parts as well. We can see the bill of materials as well. For any assembly you click on, you can see the complete bill of material is shown in the Windows Explorer interface of our SolidWorks Enterprise PDM. Okay, you can just see the nice preview as well, where we have a nice preview window. You can just see the references where it is used and all in this particular Windows itself. Again, we can see the drawings, whatever you have created for this particular sub-assembly. But we are mostly interested in this particular wheel rim. You can see again, I can just check the complete BOM which is required for the purchase department. I don't need to go to the CAD software for that. I can just check the BOM. I can just save the BOM from here as well. You can see the BOM, the named BOM is here. You can just save it and you can give it for the purchase department to the purchase department for purchasing the components. So once we have gone through all this complete sub-assembly, I can just quickly go and open the assembly which I'm interested in. I'll just check out this assembly. So quickly check it out. You can see the sub-assembly is in front of us. Okay, I'll just go and show you the exploded view. Okay, the exploded is like this. Okay, you can see the complete sub-assembly of this wheel part, what we have here. Okay, once we are done, I am mostly interested into designing of this particular rim. So let's get started designing the rim portion. So actually the manufacturing process that this company uses is a casting process to manufacture the wheel. There are different processes that are there for manufacturing this wheel, but we are using the casting process. So as soon as I say okay, I need to create a new part, it will ask me where you want to save. I'll just choose a proper project and the folder. As soon as I say, you can get a nice data card where you can just see the automatic created name for the particular part. You can type in the description. You can see the vendor. You can just choose a vendor for this particular part. Again, you can see you can type any description that you want. You can see the date when it was created, the file name, who has created it, his name, everything is given in this card, and just say create it. So you'll be going to the new document. Here I'll be creating the wheel part. Let's start with the creating some sketches. What I have here, I have a block which is already created, which is standardized block that I already have with me. I can just open the block and I can just paste it on this particular sketch plane. There is a manufacturing or maybe a designing area which is specified earlier itself, so I don't need to get out of this grid that I have here. So whatever I need to design is in between this ribs, so I can just go and start designing the wheel rim part. So you can see there are some end part, the back end, we can see there is a straight line because there is not much machining is done, so it's always straight line. I can just quickly go and revolve whatever I have sketch I have created. So you can see this is the sketch, this is the particular first feature that we create. This is a casting ROS track that we have with us. Okay, so I'll just go and check in this particular part that I've created. I'll just quickly check in and I'll send it for approval to my manager. My manager needs to check it whether everything is correct or not. If everything is correct, he'll just approve it. So you can see I have just given it for approval, so I'll just say submit for approval here. I'll write some comments. You can see we have a very nice window for writing comments to my manager. Say okay, and I'll submit it for approval. Once it's approved, once it's sent to the manager, I'll just log in as a manager and I'll log off as a designer. So as soon as my manager logs in, he'll get a nice notification on his screen. You can see their notification has been gone, and he'll come to know that there are some changes. The designer has done something on the rim part. So he'll just quickly go and open his local view. He'll quickly go and say open his local view. You can see he don't need any CAD software. He can just view the files here itself. he can just click and he can see what I have done. So you can see the change, whatever I have created can be seen here in the preview window. So you can just go and check everything. You can just check the mass, you can just check the dimensions if you want. We have a nice dynamic measuring tool here. You can just go and quickly measure whether everything is correct or not. If he finds that everything is correct, then he'll just go and say, he can just send it again back to the designer. So you can see he's sending it back to the designer because there are some more changes he requires to be done on this particular part. You can see he has sent back to the designer. So once the designer logs in the enterprise PDM, he'll again get a notification from the manager saying that there are some changes needs to be done. You can see the casting is okay. I need to add the spokes now. So I need to start creating the spoke design here. So once I check out the file, you know, these spokes whatever are designed are like first done by the design artist, and then we need to bring in those the sketches that they have drawn in SolidWorks and then start creating those ribs or the spokes that we have. So you can see I can easily bring the sketch that was created by the designer or the sketch artist, and I can just align it properly. I can just align it to the scale. I can fit properly and just take some references from this particular sketch and start creating my spokes. So you can see I can just easily go and start tracing it. I can't take reference, but as the particular image is 1:1, I can just take the references and I can just start creating my sketch for the rib that I want. I can just convert some entities from the existing edges which I have there. I can just go and quickly go and convert it. We have a very nice trimming tool inside SolidWorks which we can use to trim our sketches. I can just quickly go and trim the sketches to get the proper sketch. Okay, use some center lines so we can add some proper values to it. Okay, so it's a dynamic. Okay, fine. So we have this sketch with us. We can just go and add the feature. I'll just say okay to it. We have the feature which is cut. Okay, I just need to revolve it. So I just need to have a circular pattern. I can just quickly go to the circular pattern. I can just choose the feature that I've created. I'll choose a proper axis, say okay to it. The instances that you want, you just specify it. Just say okay to it. We have the instances. You can see how easily we can create those spokes that we need. I need to add some holes now. So to add some holes, I'll just draw a reference circle which will be the PCD. To place my holes there, I can just quickly go and place the circle. Now I can just quickly go to the design hole wizard, where I can choose a proper hole which I need to place here in my filtering part. So let's go to the hole wizard. You can see there are different types of holes. We can just choose the specific hole that we want according to the standards. We have different standards here. You can see there are end conditions. You can just choose the proper end condition that you want to create those holes. Let's specify what is the size and the end conditions that we want. Let's go to the position part of it. Okay, let's go and say position, and let's say 3D sketch, and let's place the hole that is desired. Once the hole is placed, that I just need to do a circular pattern for that hole as well. I can just quickly go back to the circular pattern. Let's select a proper axis or maybe some circle. I can just choose some reference how to pattern it. Let's choose the instances, and we have the holes there. Once the holes are placed, to make it more aesthetic and to add some strength, I can just add some fillets to it. So we have a very nice option where we can just select one edge and it will give me different options to place the fillets. So whatever options are okay, I can just go and place the fillets there. I just want it on some edges, so I have just placed it on some edges. If you want to just resize it, I can just go and change the fillet to the desired size. I can just resize it. You can see the fillet will be resized, and our wheel rim part is the ribs are completed. Once the ribs are completed, now I need to check it back in the vault. Okay, I just need to add some comments. Let's add some comments to this. Let's say spoke design is ready, and say submit. I just need to again send it for approval for my manager to see and look at it. Okay, before that I'll just show you some versions. You can see we can just whatever modifications we have done will be recorded as different versions, and we can anytime go back to the version which is desired. So you'll have the complete data from the scratch whenever you have started designing it. So we have the complete record of whatever changes have been done to this particular part, who has done it, what date he has done it. Once it's done, we can just send it to the manager. I'll just send it to the manager to see whether everything is correct or not, the spoke design, whether he agrees to it. So I'll just send it to him. Once I send it to him, I'll just close this and I'll log in again as a manager. Let's quickly go and log in as a manager here. Okay, log off as a designer. Let's go and log in as a manager. Once the manager logs in, he'll again get a nice notification saying that the spoke design is complete. Log in as a manager. Okay, we have the notification. He says, okay, spoke design is complete. Let's go and review it. He'll just open it in the preview window. He can just see what are the changes I have done to the raw stack that I have forwarded him. So you can see, okay, so these are the changes that he'll see. Okay, everything is correct. You can see he can be able to see everything in the preview window. He can see the versions. He can see the data card again. Once he has done reviewing everything, what he'll requires is there are some more changes which are required. So he'll again send it for some changes. He is asking me to create some more variants of this particular design because there are many wheel rim types. You can see there are a lot many automotives running on the road today, and you can see those many variations we see for the wheel rims as well. So he has asked me to create some configurations for this particular wheel rim. So I'll just go back and I'll log in as a designer now. And as soon as I log in as a designer again, I'll get a pop-up saying that there are some changes which are need to be done to this particular wheel rim. Okay, you can see there are some changes. He is asked for some different configurations to be created for this particular wheel rim. I'll just discard this message. I'll go back to my wall. Okay, so you can see there are some configurations which I have created quickly. You can see as soon as I switch between the configurations, you can see different configurations. Even I can add different equations to drive this configuration. I have created a nice global variable here. As soon as I click and change the global variable size, it changes the size of the particular wheel rim. So I don't need to worry about that. I can just quickly go back to the global variable, change the global variable, and I can just see the changing wheel size. Okay, so these are some.
Okay. Till now we have seen great capabilities of SolidWorks regarding sketch tools, advanced part modeling, etc. Now let us see how we can make use of DriveWorks Express functionality to create a design automation. DriveWorks is a design automation tool used to capture and reuse the design knowledge to save time and money. It uses design rules to minimize errors and the cost of manual mistakes. It will also liberate design engineers from repetitive tasks to and it will help us concentrate them on new and special design. Now let us take example of our rim. Okay. Now as you know that there could be large number of variants of rim model. It will be very cumbersome to generate different variants of rim every time a new inquiry is reached to a design engineer. So by using DriveWorks Express, we can define a rule for model, and by using logic in terms of various forms, it will be created to define a design database. Okay. Now you can see on the right hand side of the property manager, you can see DriveWorks Express property manager, and you can see there are some features and dimensions which are already added over there. And also I have linked the drawing and also I am allowing it to generate configurations for my model. You can see the dimensions are already added. Now I'm going to add a few more dimensions in front of you, such as this is the rim thickness or the thickness of a sprocket which will be added in front of you. Okay, that is the thickness of a rim. This is just defining the name of this particular dimension. Okay, once I'm done with this one, next you can see is the form interface. Okay, form are nothing but it is an interface which will collect the information regarding the input parameters to generate a model. Now I'm just going to add one parameter, that is the thickness of a sprocket that we have added just now. Okay, so here you can see that I'm going to add a rim thickness. Okay, this is a form which will be added in the input parameters. Okay, this is just a name that I'm going to define thickness of a sprocket. Then I'm just going to apply a spin button increment. Okay, where I can specify minimum value as a 2 mm, maximum value 6 mm as a thickness for a sprocket. Okay, and it will be incremented in the intervals of 0.5. Next, this is again a rules button. This is a rules tab actually. Here you can see I'm going to define a rule for this thickness by taking an input actually from this thickness. Okay, once I'm done with this, you can see that now I'm going to create, or I'm going to use a database. Okay, I'm just going to delete. Okay, here I'll be switched to this particular database which is already saved in the design folder over here. Okay, this is a DriveWorks Express. Okay, so this is rim DriveWorks as the database name. Okay, now you can see that I will be selecting a customer name over here. Okay, now I'm just simply closing the model, which states that I don't no longer have to keep the model open. So this is a customer name XYZ. Then I'm just going to define a designer ribs, and then diameter of a rim would be 22. Number of rims, number of sprockets would be 4, and hence I'm going to generate this particular model. Now you can see how SolidWorks will automatically generate a model or a configuration for my input parameters. Also, you can see that drawing is also updated in real time by using DriveWorks Express, and you can see this is the model which is generated as a result of our input parameters. Thank you.
We have seen some of the DriveWorks capabilities here. Okay, let's see the drawing part of it now. I'll just quickly go and create a drawing for this particular rim part. Just say okay. You can see it will again pop up the data card. I can just fill in the details about this data card, and I'll just go to the drawing sheet now. Just say okay. Let's go and just refresh the view palette view. I can just drag and drop the desired view on my drawing sheet, and you can see all the views will be automatically dropped. I mean, we don't have to work a lot for dragging and dropping the views on the drawing sheet. So we have all the views, and you can see the dimensions are also there, so you don't need to worry about the dimensions as well. You can see as soon as I drag and drop the views, the dimensions also comes along with the views. So a lot of time is saved for adding dimensions separately, or maybe giving the dimensions one by one. So if you want, you can just make some changes. You can just clean up the drawing as required. Whatever dimensions you need, you can just clean up, and you can just place the dimensions accordingly. So we have all the dimensions in the particular drawing that we required. Let's go and create a section view, which is some more details that I need to add to the drawing. So I'll just quickly go to the section view part of it. I can just quickly create a nice half section. You can see this is a nice capability in SolidWorks 2013 that is brought up, and we have a nice section view. To clean up this, I can just remove the tangent edges that we have. I can just quickly go and say remove the tangent edges. So the tangent edges will be removed. To see whether the section view that has been created is properly created or not, to see it, I can just rotate it properly. I can just see everything is correct or not in all the directions. Everything is correct. So I can just say cancel. My section view is perfectly done. I can just place it. I can just dimension if I want. I can just show you how we can dimension it. So I again need a detail view of this particular rib part. I can just bring out the rib detail view separately. I can just start dimensioning the ribs to give it more detailed dimensions. I can just place the dimension the way I want it. Okay, so you can see how I can just place the dimensions and just say okay. So the drawing is ready for this particular field rim. I can just quickly go and review. I can just go and quickly go back to the part and submit it again to the manager for approval. So you can see once I have created all the configurations, I have shown you the configurations. So all the configurations are done, whatever my manager desired. Let's go and see the assemblies. I'll just go and select a template for creating the assembly from this part. I'll bring this part in the assembly environment. Let's browse for some other parts. Let's start with assembling a tire to this particular wheel rim. I'll bring the tire part. Let's go and search for it. If this is a tire part, I can just open it. Let's open it in its own window. Okay, let's quickly go and open. We have the tire part here. We can just assemble it. Now assembling, I'll use a SmartMate technology. As you can see, I can just hold this particular edge and I can just drag and drop it and it will be in place. Let me bring some other component as well. I'll just go and bring the sub-assembly of the brakes that we have here. I can just go and bring it and drop it in the assembly environment. Now again, assembling this particular sub-assembly, I'll use the SmartMate technology. I'll just drag and drop this particular edge on that particular face of the rim, and you can see how easily it gets assembled there. Now let's go and create a nice exploded view. I can just bring out parts. There are two ways of doing it. We can do it automatically and manually as well. This is the manual way of doing it. It's again because I need a desired exploded view, I can just bring out all the parts that I need. Okay, let's quickly bring out them. You can see it's very easy. You just need to pull that triad arrow in the direction you want to explode the component, and we have the exploded view created here. Once it's exploded, I'll just show you the animation. You can see how it is animated. We can give this animation. You can save it as AVI file as well for assembly instructions if you want to give it on the shop floor. Once the animation is done, let's go and create an assembly drawing of this particular assembly quickly. Let's go and say create assembly, and I'll just select a proper template. Let's say create assembly. Okay, I'll just bring some of the views on the drawing sheet. Let's bring this front view first. Okay, I can just show it in exploded state. Let's put off some of the coordinates that we can see there. I can just rotate it as well on the drawing sheet to get a desired placement. Let's go and give an auto balloon. You can see I have just placed auto balloons. There's a nice magnet plane with the help of which we can place the balloons very nicely in the proper manner. Let's bring up some other components, other views as well, and just place them on the drawing sheet. Next thing I need is a bill of material. I can just go and right click and say tables bill of materials, and it will pop up the bill of material. It is again associative bill of material. You can see how easy it is to bring up the bill of material.
Once the design part is completed by the designer, so he has sent review to the manager. So once the manager logs into his account, so he will get pop-up from the designer. Then he will enter into the vault and he will go through the model. So once he is satisfied with the requirements of the model, so he will send for the validation to the analyst team. So here the manager has given all required information to go ahead for the validation of the wheel rim to the analyst. So as per the requirements, the analyst need to perform 3 different studies on this wheel rim, that is static analysis, fatigue analysis and frequency analysis. Along with these studies, he also needs to perform optimization study for the wheel rim considering different materials. So when the analyst logs into his account, so he will get a pop-up from the manager saying he need to perform the 3 studies as well as the optimum analysis, optimization also. And we know in most of the wheel rim manufacturing companies, aluminum alloy, that is A356, is commonly used. So here in our study we will consider aluminum A356 as the initial material. First we will go ahead with static study. As you can see, this is the static analysis which is already done, and here we have applied fixture to the 5 holes, and we have applied a maximum pressure which is about 100 psi throughout the circumferential area of the rim. So we have stress plot, displacement, strain plot here, and we are getting a maximum of 83 megapascal of von Mises, which is well below than the yield strength of the material. That is why we say it as a safe design. Since the rim is subjected to cyclic loading condition in actual scenario, we need to perform fatigue analysis to predict the life, and this is where we have created a event. And to go with fatigue analysis, we need to apply SN properties. So we have that option in the material library. If we have customized SN properties, we can feed it, else we can calculate it from using the Young's modulus of the material. So this is the plot where we can see the total life of the wheel rim. If it is showing 10 power 5 or more than 10 power 5, then as per the theory we consider that one has infinite life. Since in the wheel rim is subjected to vibrational loads, so it is also necessary to perform frequency analysis also to know what are the natural frequencies, and this is where the outcome of the frequency analysis are different frequencies and their modes of shape. You can just compare these with the working frequency, and you can check for whether there is chance of resonance or not. So as per the final requirement, we also need to perform a design optimization study on this one, considering variable as a pattern that represents number of spokes. So minimum we have considered 4 and maximum 6, and consider step size as 1. And we have 3 different materials here, that is zinc, aluminum alloy and magnesium. So we have a common constraint here, that is stress should not go beyond 150 MPa, and our final goal behind this optimization is minimizing the mass. So as per these variables, optimization study has created 9 scenarios, and it will calculate the mass as well as stress for all the all these scenarios. So among these scenarios we can see that magnesium alloy, when we use magnesium alloy and pattern that is spokes as 4, so we are getting a maximum stress of 83, which is well below than the yield strength, that is 150 MPa, and we are getting a mass of 12 kg in this case. So initial weight was 21 kg, wherein the optimum is giving 12 kg. So this is how optimization study helps us to reduce a lot of time during the design stage itself, and this is where we can see different reports generated from simulation, and we can even share all these reports with our manager or vendor. So it will be having all the boundary conditions, results, everything related to each of these studies. Okay, so finally the designer will be sending all the reports to his manager, and he's saying analysis has been done and it looks like safe in this particular loading condition. Then he will ask for the verification of the designer designs. So when the manager logs into his account, so he will be getting the same notification, that is he need to verify that the work which was done by the analyst person. So he will enter into his vault. So he'll go through the reports here. So he will review the design by going through the reports which was generated using simulation. So once the review is completed, the simulation manager will be sending this to the final to his head. So as we can see, he's going through each of these studies, he's reviewing. So once the review is complete, so he is asking, he is sending his report to his manager. Then when the manager go through the final review of the results what the analyst person has done, so again he says the design looks good, but still he wanted to do some material optimization considering thermoplastic polymer as the material, and he is asking the designer to use any of the thermoplastic polymer, since thermoplastic polymer has got many advantages over the metallic wheels. So the designer has considered thermoplastic polymer in this case, and he has used same boundary conditions, and compared to the earlier study, here we are getting a little bit higher magnitude of stresses, but still the design is safe, which is well below than 150 MPa. So we can consider this as a safer design. Since we are considering thermoplastic material here, so we need to perform even environmental impact of the design. So we have sustainability tool, so we can choose different thermoplastic polymers from the library, and we can check for the environmental impact in terms of carbon footprint, energy consumption, air impact, and impact over the water. And the manufacturing region, usage area, how much power consumption will be there throughout its life cycle, what would be its life. So when we feed all these things, depending on the Gabi data, so sustainability does environmental assessment. We also have capability to find similar materials by changing properties like density or its strength also. So this is how we are getting different varieties of material. So by choosing each one of them, we can see the environmental impact during the design stage itself. So once that is done, the analyst person is sending a reporting back to the manager. So he says even this design is also safer and also environmental friendly. So finally, when the manager logs into his account, so he will be getting notification from the analyst person saying for the wheel rim he has considered a thermoplastic polymer in this case, and the design looks safer. So finally the manager will go through the report which was generated for the thermoplastic polymer. Since plastic has got more corrosion resistance and light in weight, so nowadays most of the companies are turning towards plastic rims. So once the review is complete by the manager, so he will be sending the feedback to the analyst person. So this is where we can see once the review is done, he says design is safe, and he's just reporting to both analyst as well as the middle manager. So this is the top management who has got notification from the simulation manager. So final review is done by this person. So he will be going through the report once again. So from the vault he has directly opened the report and he has just gone through the results of the wheel rim, and this is how he has given the final approval for the wheel rim. So now he says part is ready for manufacturing and upload.
Hello, welcome back to the part of SolidWorks Plastics, wherein in this design process we got to know from the manager that replacement is essential for reduction in weight of the part, that is rim. Manager suggested us that if we use a lightweight part for this, and we can have better results, and also we can reduce some cost. So it's already proven in the market that there are nylon wheels coming on to the market, while nylon rim. Based on that input, designer verified whether we as a designer verified that we can apply nylon material, ultramid nylon from BASF, so that it can replace this manganese bronze alloys. So how do we are going to do that? If we apply plastics, if we make the rim out of plastics, that is nylon material, how it is going to be manufactured? We can manufacture it or produce it by injection molding technology. While if I say injection molding technology, what are the manufacturing defects I may face? So all those things we have to check. For that we have a tool called SolidWorks Plastics. Again, without leaving the window, we can have a total solution if there is a change in the design like this, if there is a change in the material, if we have to replace some steel from plastics, and if we have to see the manufacturability of plastics. We have SolidWorks Plastics, wherein what we can see here is SolidWorks Plastics, where there are two variants called SolidWorks Plastics Professional as well as Plastics Premium. Professional helps us in predicting the manufacturing defects early in the stage of design itself, wherein how my part will fill, whether there are weld lines, what are the gate locations, all those things. So for that, the minimum input is needed, we have to mesh it. Meshing, it can be solid, which is hexahedral, and shell mesh, where it is for thin parts. For the thick parts, thick wall thickness, it is solid. And we have to input the material. Here we have chosen the material. If I open the database, I can source the material using default data bank, wherein I have all the resin combinations, ABS, ABS-PA, ABS-P6, and so on. We have abundance of library available. There are so many resins available. I can also sort by family of the material, and then the chemical names of the materials in the market, or as well as the providers, manufacturers of these resins, like 3M, Lord, Applied Signal, Asahi, BASF. Now here for this project we are going to select BASF. In the BASF we are going to choose Ultramid, PA Ultramid, that is nylon 6 Ultramid material, which is going to be used for this alloy wheel, replacement of alloy wheel. Now the material is chosen. We have to assign the machine settings. In the machine settings, we can see all the default machines, as well as all the manufacturers machines like Arberg, Cincinnati Milacron, Sumitomo, Battenfeld, JSW, which are there available in the market. If not, I can also define my own machine in the user defined column by describing all the specifications like injection unit, clamping unit, hydraulic unit, and all these specifications. Now we'll go for this project. We'll go with the default machine settings, and flow settings and pack settings can be added for the process, where the filling time, melt temperature, mold temperature can be assigned, or it can be set auto. And also the gate locations. If I just open the gate locations, I can ask the software to assign the gate locations automatically by selecting this option, add gates automatically and predict flow pattern. And I can also manually add the gates. Here in this we have added 3 gates for this material, as the volume of this is big, and it selects the diameter of the gate and all automatically. Now once these inputs, the minimum inputs, are given, I can run the analysis results by just double clicking on flow or flow plus pack. If I am a professional user, I can see flow here. If I am a premium user, I can see flow and pack, both the analysis here. Now once I run the analysis, I can see the results, and I can also make the reports of this summary and reports of these very easily. Now if I see the results, flow results of this particular material, I can see the fill time animated with the gates provided using the automatical gate detection and the software available in the software, wherein I can see a short fill of the component here. Gates are not sufficient, the gate locations are, the gates diameters are not sufficient, or gate is not proper to fill this complete component. That is what the analysis says. Now pressure at the end of the fill and temperature at the end of the fill, ease of fill, all these things I can predict, and I can also see the velocity vectors at the end of fill, and also I can see XY plot of the same. And now also these results, based on these results, I can fine tune my design and make it manufacturable without any manufacturing defects in the molding, so that in this process, without leaving a window, we are getting the complete solution for even these type of applications. And in the meanwhile, we are saving a lot of time, and also one mold rework would be much costlier than the entire thing. So we are avoiding the rework of the molds, which proves to be very costly, and also it is time taking, so that we cannot be delivering the mold in the time. So all these things can be avoided, and we can predict the manufacturing defects very easily in SolidWorks Plastrix. Now if we see the summary and report, I can just right click and say generate, so that it will ask me for some basic information of what is the title, and what is the date, and the department, institute and author, and so on. And in the introduction, I can write notes, special notes, and also I can generate the image files. I can select all. I can also produce videos by selecting the AVI option, and I can say OK. It gives me the report completely with all the parameters we have given as an input, and also the results of the particular thing, analysis what we have performed on this, so that it is easy for the designer to predict the manufacturing defects and correct it early in the stage of the design, so that there won't be any red cards for the mold from the production to come out to the maintenance area. So now the report looks like this in a Word format, wherein the report, the title and all, however we have given, and also the content, introduction, model, material, process conditions, everything will be automatically taken, and it creates the report, so that which is very much useful for sharing the information with the design team and the manufacturing team, and also the management team to decide how to go about it, and also for the modifications which is necessary from the end customer. So I can see all these reports generated in Word format as well as PowerPoint presentation. All the school information, flow pack information, material information are included in this particular report, so that we can find solution for molding also inside SolidWorks itself without leaving the window. Thank you very much. Hello and welcome to the part of this demo where we are going to see the technical communication and documentation using SolidWorks Composer. SolidWorks Composer, also known as 3D Composer, is a 3D technical communication software that lets us clearly explain our products using existing CAD data. A flexible, easy-to-use desktop content creation system, SolidWorks Composer streamlines the creation of technical illustration for product demonstration, product documentation. For more dynamic product communication needs, SolidWorks Composer also provides a highly efficient platform for creating animated 3D assembly and maintenance instructions and also interactive marketing collaterals. Based on the lightweight XML architecture built, SolidWorks Composer also allows non-technical users to create 2D and 3D deliverables directly from CAD data. By leveraging existing product design and existing CAD data, we can do the documentation process parallelly, so that we are going to lower the costs as well as we are very much well in time to market. So what we are going to see now is the 3D or SolidWorks Composer, wherein I can see all these files which can be opened directly from the SolidWorks Composer, and what we see on the screen is a buggy vehicle design, wherein we can create images like this once it is taken into the 3D Composer or SolidWorks Composer. And also I can select marketing collateral images like this, where to position and how it looks in the background, how it looks in different environments and all those things. And also I can place it in the front cover of my collaterals or technical illustrations and so on. So top view for the wireframes can be done, and any number of views I can create by just clicking a button here by setting the view according to my requirement in the viewport. Now if I have to add some details, for example, here there are two markups, there are two labels which says suspension and brake system. Now just we want to create an image or a detailed view of those particular systems, suspension and brake systems. Here what we can do is we can just go to Digger. I have something called as Digger tool, wherein it helps me to create the detailed views very fast and very accurate. Now I just click on this spanner icon, I'll get the options that can be used, and now this plus button is to change the center of interest, that is area of interest what I'm looking at. I just place it near the suspension system, and what I can see here is onion skin. You can see the onion skin view, and here by dragging this bar I can see the details opening up. And then this is an X-ray view, wherein I can see the X-ray view of all others except for the point of interest selected. Or also I can see a zoom view. Now here I would feel the zoom view of the suspension system would be appropriate to capture for making it as an image in the illustration or manual. I just select this capture. I just select this option, capture picture in 2D, so that I can see the image. Now same way I will also have to have detailed information or Digger information on brake systems also. I just select again the Digger and I change the location, and then change the area of interest, and then what type of view I want, so that you can see it here. I can just select the dragger here, so that the percentage of zoom can be set, and I just capture this picture also in 2D. So like this I can create any number of views, and I can also create a new view for this, or I just right click and say update view, so that this particular view, whatever I have selected, is updated with whatever the changes I did now. Same way we can also have different frames, different tires or different wheels, and this would be helpful for me to publish in my website, so that user can then and there choose and see how it looks when there are different options. Now for example, here I have green frame and black frame. I just come out of the design mode and I just click on the green frame, so that I can see the frame's colors changes into green. I just come back and I can also see it on the black frame. I just click on the black frame, I can see that black frame color is changed, and you can see have a look at that. When we publish these type of things into HTML or web applications, it would be useful for the end user to, it will be very helpful and attractive for the end user to do all these things. Same way we can also have different frame designs and also break systems here. Exploded view with a technical view, wherein I can also set different illustrations, technical illustrations, SVG formats. I can just say save as and save it somewhere so that I can open it and see how it looks. See, now before making it as an SVG file or before making it as a technical illustration file, I would like to add BOM also for this. I can just go to BOM here, bill of materials. I can add different settings, visible geometry, selection, all geometry and all those things, and I say generate BOM IDs and say show hide BOM table. I can see the BOM for this particular assembly exploded. Now also it is interactive, wherein I can move my cursor on the bill of materials, it highlights the parts and vice versa. Now this, I just make this as a technical illustration image, and I just set all the views here and I say save as in the desktop, so that now if we see that in the opening that particular view, I can see this view in an SVG format, wherein I can see all the details. I just double click here, we can see it here. You can see all the details. And the same way, I just hover my mouse on the parts here, it highlights the item in the BOM as well. So this is how we can create all these communications and other things very easily. And now for different types of wheels, I can just double click here. I can also save or update this view. I just say update. Whatever the changes we have done, we just need to update. Now here I have wheel type A and wheel type B. I just want to set this to wheel type B. I just want to link this to wheel type B. Nothing is going to change now, but it is back. But if I want the wheel type B to be there, placed in place of this, I just need to do a little activity wherein I get into the design mode and I select this and I link this label to the view which I am going to select, which I want to appear when I just click on this button. Now I say wheel type B here, that is the view which I have already created. I'm just linking that view here. Now I'm just done. I just come out of design mode. Now if I click on wheel type B, it automatically changes into different wheel. Now this wheel is captured. Now I just go back. Here it is a different wheel. I just click on wheel type B, it changes the wheel to another one. So this easy to create the views, and also captures everything. And now if I want all these things, all these whatever we have created as a high resolution images, I just have a workshop wherein I can set the high resolution image property, and I can also see the preview. And with the help of the preview, I can set the pixels, DPI, size, anti-aliasing mode, and multiple. If I have to get everything in once, I can use document paper, remove ground, white background. All these settings can be set multiple, and I just give a link, project buggy, and I can say save as in a folder on desktop, for example, and I save it, so that all the images in one shot can get updated in few seconds, so that we can use those images for our activities. So it updates everything, and it also captures the images, everything. Also, not only this, I can also create technical illustrations very easily. That is, and also the instructions, workshop instructions very easily. So that here I just have this wheel. I can set set any one particular area of the assembly, and I can make it visible, and I can make the picture of view of that. So that what we are seeing here is that now I want to go ahead and I want to animate this. Let us see how it is going to work. Nothing is working out here now, so we have to create an animation here. So how we are going to create the animation? Now here it is there. Now how we are going to create these kind of animations? I just select wheel. Now I just come into animation mode. Now I just want to replace a part here. We are going to create an animation. Now I select all these keys and I delete keys, so that we are going to create a fresh animation here. What we have seen is a sample. Now I can set this animation here, and view which I want to have, I just select this view, and I can also hide this. This is the view I need to have. I say set camera key. Now my timeline is here at the 0, and I set my camera key here, set camera keys. Now I start animating. Before starting animating, I just select which all has to come out, and I just drag this. Transform, bring it out, and I want at this time it has to fade out, so that it will be faded out. Now select the next part which has to be moved out, and set location key, and then move it to time zone we want, and then drag it out, and I want the effect to be hot spotted there. Now I want one label there, wherein it says replace this part. Now let us see how it has come out. Now till whatever we have seen, I just select all these and I just drag it and right click here and say invert time selection. So this gives me the closed loop of the video. Let us have a look on it, how it works. So these are animations can be made much easier. I just stop and go to the next level, wherein I just want to replace a wheel which is of a new design now. Now in the design, modifications are bound to happen, so the changes are bound to happen. Now what if there is a design change tomorrow when I do a complete set of instructions work and other things? Now I just want to replace the wheel as per the design change. So what I need to do is I just need to say file update SolidWorks Composer document with a revision file, and I say update, so that all my views, all my components of that particular change happened will get updated in one shot. What we can see here is it is updated with a revision wheel throughout, and also that is updated in all the other views as well. So this easy to change or this easy to update the modifications, whatever it is happening throughout the design process, so that the process can be very much parallel, and we save a lot of time in waiting till the design ends and then to start documentation. It can be parallel, and we save a lot of time. Time is equal to money, and we save we can be very much early in the market. Thank you very much.